everyone, this is Miriam from Algolaser. Today let's welcome our guest, Dr. Ding, our tech advisor of our laser engraver.
Hi everyone, I'm Liang from X-Photonics.
So Dr. Ding, would you please tell us a bit more about yourself?
Yeah, sure. So right now I'm working on the research and development of the data laser, also known as a semiconductor laser in X-Photonics, which supply blue data laser modular to Algolaser.
Okay. We are so excited to have you join us today for some important news for our product.
Thanks.
So let me start a simple question. Why do you choose this industry?
First of all, I think it's by luck or by timing, because the X-Photonics contacted me once I left my last job. And more importantly, I have a very good expectation of the data laser industry. I mean, the laser has been widely used in the areas such as the industrial material processing, the biomedical treatment, communications, scientific research, and consumer electronics. The data laser is the cornerstone of the whole laser industry. So it's still booming. It's a thriving industry. So laser is also known as the fastest knife. I mean, the most accurate ruler and also the brightest light. I mean, no one can say no to a job like research on the laser. I mean, once you have watched the Star Wars movies, I mean, it's really cool, sounds really cool. So, and also this job pays better salary, so I say, why not give it a try? So I take the job and has been working on this area for like 2 years.
As we mentioned in our earlier live streaming show, our laser module adopts cost solution. So would you please introduce more about the cost solution?
Yeah, so first of all, COS is the abbreviation of the chip on submount. It refers to a certain type of die package where the laser die is soldered to a thermal expansion coefficient matched substrate, also known as substrate, with a golden tin soldering material. So the COS is usually used for high power laser diodes packaging, as it has the merits of good heat dissipation capability. It is size small and it is easy to be integrated. So taking X-Photonics 40 watts blue dye laser modular, for example, it packages about 8 COS laser diodes inside this copper housing. So after soldering these chips onto the copper housing, and the multiple laser beams from these diodes will go through beam shaping, optical beam shaping, and it will be combined in the space and finally focused at this working point far from the housing with a group of optical lenses. So, and the last step would be the sealing of the housing using parallel seam sealing technique to ensure that this housing is totally sealed to improve its reliability. Okay.
So could you please tell us what's the difference between COS and TOCAN solutions?
Yeah, okay. So TOCAN is another type of laser diode package, where a small pieces of COS diode is packaged inside a copper can with transparent thin glasses or lenses as the output window. So there are several differences between the COS and TOCAN diode laser modulars. So first of all, they use different laser diodes, quite obviously. One packages COS diode, while another packages the TOCAN diode. So if we take COS as the preliminary packaging of the diode, so the COS-based diode laser modulars corresponds to the double package of the diode, while the TOCAN laser diode modular corresponds to the triple packaging of the laser diodes. So they are also different in terms of their production process, the air tightness, the dissipation capabilities, also the size of this whole modular. So the combined effect of all these elements will result in the differences in terms of performance, the long-time reliability, and even the production yield of these diode laser modulars.
So could you please share us more about these features?
Oh, yeah, sure. So we have discussed some differences between the Corsair laser diode modular and the token laser diode modular. So the Corsair solution corresponds to a double package, while the token solution corresponds to the triple package of the diodes. For the manufacturing, the production process of the Corsair diode laser modular is more simple. First of all, the Corsair diodes will be soldered onto a copper housing with the composite metal soldering material. Then, after delicate optical coupling, all the diodes and the lenses will be totally sealed in the housing with the parallel seam sealing technique. The token solution, on the other hand, is more complicated. Taking 20 watts modular, for example, the token shall first be uncapped so that the optical coupling can proceed. And in some cases, the uncapped token will be recapped again after fast access collimation. Then the recapped token will be glued onto a metal housing to do the following optical coupling. Then the final step would be the glue sealing of the whole package. Due to different packaging strategy, the Corsair diode laser modular theoretically has better air tightness than the token packaged modular. So with the seam sealing and the glass soldering techniques, the Corsair diode laser modular can achieve atom level hermetic sealing. As for the token solution, the sealing is non-hermetic, which means that all the optical element is vulnerable against the humidity if the modular is operating in a high humidity environment in a long term. So as for the thermal stability, the heat created by the diodes is dissipated along a shorter path in the Corsair laser diodes packaged modular, as the Corsair diodes are packaged only twice. Also, the soldering material that fixed the Corsair diodes onto the housing is a composite metal, while the token diodes are attached to the housing with the glue. Therefore, the thermal resistance of the Corsair modular is expected to be lower, which contributing to better heat dissipation capability.
So I guess they are also the reason why we choose Corsair solution. As you said, we are using different methods in production, packing, air tightness, and heat dissipation. But how will they benefit our end users?
Just as you concluded, theoretically, the Corsair diode laser modular shall have better lifetime and better reliability in terms of long-time operation. Therefore, it will provide our customers with a lower total cost of ownership.
Can you expand on that?
Yeah, sure. So right now, the overall price of core solution is higher, but considering its advantage on the reliability, the core solution's total cost of ownership in the long term is lower. And on the other hand, the token laser diode is designed for the illumination and projection application, while the Corsair laser diode is considered a better solution for high-power diode laser packaging for its compact size and heat dissipation features. So I believe that with the expanding consumer electronics and industrial material processing market, the price per watt of the core solution will keep on declining. So in conclusion, the total price of ownership of the core solution is more competitive, and Photonics will keep on its research and iteration of our coarse-dyed laser modulars and systems.
Okay, can I put it in this way? From long-term perspective, even though the price of our laser module is higher, but this solution will allow a longer life cycle. So obviously, the total cost of ownership of our machine is much lower.
Yeah, I believe that. Okay.
Thanks for sharing this knowledge of laser module. So I want to know what's your expectations for this industry.
Okay, so currently the industrial application takes the largest scale of the laser engraving market, and the industrial laser engraving machine utilizes lasers such as carbon dioxide gas laser, the fiber laser, solid state laser, and ultra fast laser, and all these different types engraving lasers focus on the high precision, faster speed, and multi-dimension engravings. And I believe that one trend in this laser engraving market is just as Algolaser is trying to do, is to minimize the size of this industrial laser, lower their cost, and so that making these industrial lasers available for consumer electronics level engraving applications, and also making them available to ordinary families. And another point worth noticing is the fast development of the blue dyed laser. Yeah, I believe that the blue dyed laser used for engraving emerged in market not quite long ago, right? And it has developed quite fast, and its output power has risen from 1.6 watts in 2019 to all the way up to about 20 watts or even 40 watts, 40 watts in 2023.
Yeah.
And its application has expanded quite a lot, including the laser, wood, and colored plastic engraving and cutting. And it can now even engraving these beautiful colored pictures on this stainless steel, right? So I believe that with the development of the blue laser dyed development and more invest on this area, its application in the electronics, consumer electronics will keep on expanding. It will have a very big potential application in the industrial material processing areas.
Okay, thanks for your sharing, Dr. Ding.
Okay.
And we'll call this all for today, and we will see you next time.
Okay.
Okay,
Thank you.
see you.
Thank you much. Bye.
Thank you.
Bye.